All right, so welcome to Live Coding Rust. It's been a little bit of time since I was doing live streaming, but I'm going to do this every Monday again, just really briefly. So for today, I'm going to get into a inference story, which is how to do LLM inference with Rust, and I'm going to walk through a repo. So let's go ahead and get started here. I'm going to go ahead and share my screen here. Let's see. So let's go for Chrome, a Chrome tab here. Give me 1 second. I gotta change this. Okay, back here, and I'm going to share this window. Perfect. There we go. Looks good. And I'm gonna zoom it a little bit to make it a little bit bigger. Perfect. All right, so to start off with, I have GitHub here. I'm going to move to an organization where I have a bunch of code, and I've got a Rust candle repo here. So let's talk about what this is real quick. So Rust candle is pretty interesting because it allows you to play around with large language models. I think there's not many people doing this, and this framework is pretty awesome. And we can actually take a look at this if we just go to Hugging Face Candle. Go here, you can see that here's the repo. It's a minimalistic framework for doing machine learning in Rust. But if you take a look at this, you can see that essentially every cool large language model is a one-liner, right? So to me, this is very compelling, right? You don't have to do anything other than have Rust installed on your machine. So that's the overview of what I'm going to cover. You can see here that you can do all these different things with it, and you can see, in fact, that you can, basically target a GPU as well. And again, it's just a one-liner to get this running. So in order to get this working, what I did was I set up something called a dev container. What is a dev container? Basically, it's a configuration that allows you to use a pre-configured Docker file. So you can see here I use Rust. Rust is already installed. I have some other things like CUDA, which is important. Like if you need to do things with a GPU, you need to have CUDA installed. In this case, I'm specifically saying the CUDA versions that I need and the toolkit, etc. And then I do a little bit of tweaking here for some other things. And then in terms of the dev container here as well, I actually have enabled certain features as well that are inside of here. So once you get all that set up, what's cool is that all you need to do for GitHub Codespaces is go to code. And let me just show you how you would set this up. If you wanted to set up a code space, you click on this and you say new with options. And what's really killer about this is I can then trigger a GPU. So a lot of people don't have access to NVIDIA GPUs. It's a pretty tricky thing to do. But in this scenario, we do get access to it, and that allows us to do prototyping. So I'm going to go back to my environment here, and I'm going to launch a GPU that I've already got running. So let's go ahead and click this button. So once you click this, I can then go into my environment here. And if we take a look at it, you can see that I can really kick the tires here and just make sure that everything works. So the first thing that I would do if you're going to use Hugging Face Candle in Rust is see, does does anything work, right? So if I say rust c dash dash version, there we go. We see that actually there is Rust 1.72, which is great. We also would want to see that the GPU is working. So typically what I do is I type in NVIDIA SMI L1 like this. So basically loop and like show me like a resource diagram for the GPU. So we say, okay, that works. So looks like things are working. And now, because all those things are working, I can start playing around with the interface of Candle. And it's pretty easy to actually do this. So I can just run one of these commands here. So this might be a good one to do, which would be to, let's see, let's actually verify that we can do transcoding. So that would be Whisper transcodes files. We don't have anything here. So I need to CD into the checkout. So here, notice if I say get remote -v, what I did is I actually added this repo to my environment. So I went to here, I just went to the code, and I went to local, and I did an HTTPS checkout because I'm not going to push any changes back. I just want to pull the changes. And once I do that, I CD into there. And this is a nice feature of Rust, is that I can then just start running things directly from this repo. And it's, if you're working right off of the main branch, not a bad idea to just, start going in and doing pulls all the time. But if we go through here and we do the up arrow, we can say cargo run, features, example, whisper, and we can just see what happens. So what's going to happen here is it's going to compile everything, and then it's going to attempt to run this particular job. And we could even see like what's happening when it's building. If I open up another terminal here, which we can do by going here, open up another terminal, and we could even put it up there. And then I could say htop, for example, and you can see that this is a 6-core machine, and it's essentially pegging all of the 6 cores to compile. It's not using a lot of memory, but it is using all of the cores to compile, which is nice. There we go. So now it's going to go through. It's going to download a file. It's then going to transcode it. And you can see that we're able to use the Hugging Face, or I'm sorry, the OpenAI Whisper transcoder, and we could do the NVIDIA SMI L1, and we should see this thing trigger the GPU here in a second. Let's do it one more time. Let's see if we can see this GPU get triggered. And it may have been so fast that that it wasn't even didn't even show it being used. Now, one thing I'll also point out here is that there's CUDA, which is the kind of the base level SDK for the GPU, but there's also I don't know how you pronounce it, but I think it's called CUDIN or CUDA-NN. So this is the version that's optimized for neural networks. So this is probably the one you should use if you have access to it. And if we do that feature, there's some kind of a problem here with this particular driver that I ran into. and it might be like a setup issue. So what I've done in the past here is make sure that I have everything set up here. So let's take a look at the bash RC and look at that in there. Cat bash RC. Looks like this probably is working, but maybe I need to source it or something. Source. And then if I run this again, does it work? Well, that particular feature doesn't appear to be working, but I got the other one to work, so I'm not sure what's going on with that one. What we could do though, I think one of the funner ones is Star Coder. Let's go ahead and take a look at that one. I think I have an example here. So if we do this, for example, let's go ahead and add two numbers together. And let's try that out. So Star Coder is essentially like an open source GitHub Copilot. So what's really cool about this is that you could actually use this with, again, like a GPU instance, and actually ask it for programming suggestions or whatever it is you're trying to do, without needing to use some commercial service. You could use an open source coding assistant. Now, while this thing's compiling here, let me just show you what this actually is. And if we go to Star Coder, I'm using the 1 billion parameter one, which is right here. And you can see here, this is big code Star Coder, and you can play around with it here. I think this might be GPU, or it says, yeah, CPU. So that's not going to be very fast. But this is a smaller version of the big code project. There's also the Star Coder base, and that one is using a GPU, and it's got a 15.5 billion parameter model trained on 80 programming languages. So again, the idea here is that you can actually play with that kind of stuff right in your GPU enabled Codespaces environment, which is pretty cool. You don't have to call any other service. It's just running right here locally. So let's go ahead and I guess I can keep this thing running here. We can even split it, and I guess I could even open up another terminal potentially and throw that right there. And then we could do htop. So we could see the memory CPU, and we have the GPU. That's probably a good fit to see everything going on at the same time. And now it's building it, and we're invoking it. So you should see this GPU utilization start to get hit now. Yep, there you go. So we're hitting the GPU, which is great. And now we're asking big code here, hey, build a Python function that adds two numbers. And it's going to go through here and do those. You can see here the CPU is not really being hit. All of the work, it's doing a very minor amount of CPU work. The majority of the work should be hitting the GPU for the inference. So you have to be patient when you work with large language models, because this is kind of new stuff, but that is pretty cool, right? So you didn't have to pay for a commercial service. There we go. We got inference here. Now, the other thing that we can do is we can just now start making new suggestions. Like, how about a REST function that adds two numbers, right? So let's try that out. So REST function adds two numbers, and it's going to invoke it. And again, hopefully we should see this GPU being triggered here. Yeah, I'm not exactly sure why this is necessarily needing to build again. That seems like I'm not sure why it would need to do that. There might be a flag I need to play with. But anyway, this here, Rust, there we go. We have a Rust add function as well. If I go to the documentation, let's see if we can find the way he runs it. So he says, now why does he want release? So he says here, the author says, in order to use CUDA, add dashes features CUDA. If you have CUDA in installed for even more speed up. So I thought I did have that installed. So let's see if I can run that. Let's try one more time. And let's see if CUDA in works. CUDA in. Now, so I think I'm not exporting the library correct. I've installed it successfully in the past, but I don't know why that's not working. If I say source setup, or if I just run this, maybe see if this fixes it. There's something I need to tweak to get that to working, but you probably do want that because it's just going to make your code run a little bit faster. But let's just do maybe one final example, which is let's build a node.js function that adds two numbers. And we need to tweak it back to CUDA. Go. Features CUDA. Retrieving the files. But you see, I think the reason why this is important to demo is that it shows that, in my opinion, Rust blows the barn doors off Python for LLMs. I mean, this concept of just running something without having to do all these weird Python virtual environments. Also, the Rust is very fast for inference, good at memory. And I think this is a great feature for, really diving into how to actually get better at, using LLMs is to use this Rust handle. That's probably a good, nice place to stop off. So what I would recommend is if you want to play around with this stuff, you have the Hugging Face candle repo here, which is a good place to start. We also have the repo that I set up, which is in Nogi here, orgs Nogi BJJ dashboard. And then if you go to Rust candle demos, I've set up a mostly working dev container here that you can play around with. And that would be a good place to get started with this. But hey, try it out and let me know how it works out. And I'll try to do this demo style with Rust once a week. So see you next week around the same time. All right, talk to you then.